We are going to a warm welcome to all of you, and thanks to the Amsterdam Drone Week organizers for organizing this event. Today's topic is extremely interesting. My name is Manish Khurana. I work for Eurocontrol in Brussels, and we're in the business of providing safety for aviation, particularly in air navigation. As you know, in the drones and use space world, the regulations for UAVs and drones, as well as use space, are out, and a number of them are being implemented. Member states are extremely busy and they're extremely busy in implementing these regulations. And there are different speeds at the moment across Europe. The drone traffic is expected to increase in its volume. However, to make the drone services economically viable, we need scalability. Without that, we'll have drones, but there won't be a commercially viable business. And if there isn't a commercially viable business, the chances are that it won't take off. However, for scalability, we will need to operate drones in both rural, but particularly in the urban environment as well, where the complexity is high, and the drones as part of unmanned drone family will need to coexist and be fully and safely integrated eventually with the manned aviation. Now, to achieve scalability of drones in order to make the drone service market commercially viable, we will need a number of capabilities. And really that includes things like new standards, perhaps even more improved regulations, a lot more sharing of lessons learned. But the one we're going to focus on today is technologies. We're going to need a lot more technologies to help further enable drones to ensure that the scalability in drone services market is achieved, including, of course, detect and avoid, because we need autonomy later on for drones to be able to autonomously detect each other and avoid each other. So there's a long way to go just that yet. However, there are some interesting technologies and interesting theories available that we'd like to focus on today, one of which is artificial intelligence. Now, can artificial intelligence help us in achieving scalability in the drone services market? If yes, then how? What are the known knowns and the known unknowns? And there are many unknowns right now. Do we need infrastructure to have artificial intelligence support and enable drone services market? The answer is most likely yes, we will need the infrastructure. But there's one aspect that we would like to focus today and in this webinar, and that aspect is the whole interaction of humans with drones that are enabled by artificial intelligence. Now, I think for all of you in the audience and us in the panel, we all know that the acceptance of drones in the public arena is a bit mixed at the moment. We think it's improving, and the data, as shown in the EASA report that was published a year and a half ago, and in the SESAR projects that we're all part of, shows that it is improving, but it's still mixed. How can artificial intelligence help? With me today, I have two esteemed and sound researchers from University of Munich, with whom we're going to discuss what opportunities artificial intelligence will provide to help enable drone operations, but at the same time, what new challenges that might bring to win the trust of people with a view to achieving the right level of public acceptance. So it's a bit of both. It's opportunities and it's challenges. And I'm delighted today to welcome two of the panelists who have done a lot of research on the behavioral side of human-computer interaction, and will share with us the outcome of their research, what they've done already and what they're currently doing and where they want to go, and hopefully even talk to them about their prediction for how they see the human and the computer and the drone and the technology interaction, particularly when it's enabled by artificial intelligence, will work. My first panelist is Dr. Bahadur Bahrami. Bahadur, he's from Tehran in Iran. He got his MD from University in Tehran of Medical Sciences in 2003. And then he moved to London to do a PhD in cognitive neuroscience of consciousness in the human brain, which he finished in 2008. Since then, he's worked in Denmark for 2 years and then moved back to London, where he founded the Crowd Cognition Research Lab. In 2018, he moved to the Ludwig Maximilian University in Munich, which is where he currently is. And over the past decade, Bahadur and his lab has been supported by 2 European Council research grants. And Bahadur's research focus is on cognitive and neurobiological areas of interactive decision-making between human to human, and more recently, between human to artificial intelligence agents. So welcome, Bahadur, to this panel, and we would love to listen to you later on. He will be accompanied by his colleague, who's also from the same university, and that's Dr. Jurgis Kapus. Jurgis completed his PhD in philosophy at King's College London and is now a postdoctoral researcher in the cognition, values, behavior, and crowd cognition research laboratories, again at the LMU in Munich. His research lies at the intersection of philosophy, economies, and psychology. That's going to be quite interesting because a lot of these webinars we do are quite technical, but for the first time, we're actually going to learn a bit more about the human side of it and the interaction with technology. Jurgis focuses on rational choice and game theory, and this will be visible in his presentation when he starts. And he's primarily interested in the modes of reasoning by which people arrive at personal decisions when they socially interact with fellow humans and artificial intelligence. So welcome to you, Jurgis. Welcome both gentlemen. Jurgis, what I'd like to do is perhaps for you to first share your views about the research that you've done and its findings, say for about 20 to 25 minutes. And after that, we'll have about half an hour to go through Q&A with you. Ladies and gentlemen, may I request you all to use the Q&A button in the Zoom to register your questions, and please register as many as you can. I will do my best to try and address all of them if I can in the limited time available. If you have any technical difficulties, please put your comments in the chat window where our technical experts will be able to help you. So please do register your questions in Q&A. With that, Jurgis, I leave the floor to you to share your thoughts using your presentation. So please feel free to share your presentation.
Thank you very much, Munish. Thanks for the kind introduction. Do you see my slides?
We do.
Yeah, excellent. Okay. So thanks for the invitation. And as Munish described, I'll focus here on the human side in the interaction between humans and artificial agents. Okay. So I would like you to think about this future, and I know that many of you are thinking about this future, in which we will share roads or airspace with automated vehicles, partially automated or perhaps even fully automated vehicles one day in the future. Now, when it comes to introducing this technology into our society, into our shared airspace or roads, policymakers and regulators often demand a number of things from this technology. It has to be safe, it has to be transparent, explainable, and it has to be as much as possible benevolent towards humans. And what I'm going to present here is that some of these factors, so that the more transparent, the more explainable they are, might bring up some new, unexpected, perhaps a bit surprising challenges. Okay, on the other hand, the industry promises many very nice things. For example, improved efficiency in transport, many saved lives. So it's often shown that we humans, we're not fully attentive drivers. That causes problems on the roads, accidents. And the idea is that introducing automation into our transport, we'll be able to improve that, to make our transport system more safe, more secure, and at the same time faster. So this is very nice and something that we all should be looking forward to. But what's missing in these debates so far is another question, is how will humans who will interact with these systems on roads or in airspace, how will they behave in traffic interactions? And that question is what we focus on, Bahro and I, using game theory, using interactive decision situations. So we want to study how will people react to these unmanned vehicles when they enter our roads or airspace. Okay, to a game theorist, and that's my background, many our interactions in traffic, and here I use examples from the road, they are what's called mixed motive games. They are called mixed motive games because they offer ample opportunities for us to cooperate with one another for some mutually beneficial results. Bypass one another safely in traffic, stop for one another, and so on. But at the same time, these interactions also offer many opportunities to take advantage of well-behaved other traffic participants. So if everybody around is a very nice traffic participant and follows the rules kindly, it might be tempting to then exploit their kindness and cooperation and safety to your own benefit. So if you're in a rush in traffic, you might just be tempted to hit on the accelerator and claim your right away. Here's an example of something like that happening, again, on the road. So imagine you're driving a fast car on this delightful winding road somewhere in the mountains, let's say, and then suddenly you notice that another car is approaching from a bend ahead in the opposite direction. Now, in this situation, both drivers have to quickly and without being able to explicitly communicate their intentions to one another, decide what they want to do. And what you might want to do depends on what you think the other is going to do. Now, if you think the other driver is probably very safe, it's probably going to slow down, swerve, and create a gap on the road in front, well, in that case, you don't have to do the same. You can just push on the accelerator and zoom past them. But of course, if both drivers in this situation do the same thing, then the result can be disastrous. So, to a game theorist, in a much stylized and abstracted way, this is known as the game of chicken. The one who dares wins, and the one who swerves or slows down loses. Now, it's easy for us to predict what people will do, what two human drivers will do in this situation when they encounter one another on the road and in these kind of scenarios. Well, they are both likely to slow down, swerve, and pass one another safely. Now, that kind of result is a sort of a tacit compromise between the two drivers, whereby they are kind to one another to achieve a result that's good for both of them. And it's a compromise because while they expect that the other will be kind and nice and safe, they are not tempted to then push on the accelerator and claim their right of way. In other words, to sort of be winner at the other driver's expense, forcing the other, for example, to complete halt, to swerve completely from the road to avoid a collision. So behavioral game theorists study this sort of interactions and people's willingness to cooperate with one another in labs or in online experiments. Now, usually this is done not with cars driving at fast speed against one another, but with decisions incentivized with money. You make some decisions and you can make some money. And some of the decisions, let's say cooperative decisions, might lead to an outcome where everybody makes some money and some benefit one party in the game at the expense of others. And from these experiments, we know that in this particular situation of chicken, the majority of people cooperate and they expect others to cooperate with them as well. But what we, Bahro and I, started asking a few years ago is, well, what will happen in the exactly same situations when one of the drivers, one of the players in this game, is no longer a human, but an automated artificial agent. And what we want to investigate is, what will human drivers, human traffic participants then do? Will they still opt for this mutually beneficial compromise with an artificial agent? Or will they be tempted to act more selfishly and take advantage of them for their own benefit? Okay. So we conduct these game theory experiments, both in lab and online, with a large number of human participants. And we study their willingness to cooperate with others in these settings. Now, I'm not going to go further here into specific details of game theory that we used. I'll just focus on the results. And I'm going to break down this interaction in something like the chicken game into two separate steps. So in the first step, we have a participant who needs to decide. It's somebody who is initiating the interaction. And they need to decide, will they cooperate with another, or will they play it safe and not put themselves in a risky situation? So in other words, cooperation with another, it's an invite to reach a compromise. But it's risky to cooperate with others because others might not cooperate with yourself. So here we see the first column represents people's cooperation with other people in these games. So in other words, here I am, and I need to make an initial move, and I need to choose whether I trust my partner to be cooperative with me, or whether I play it safe and don't cooperate. And we see that in human-human interactions, the majority of people trust others. They initiate cooperation. Now, the second column represents cooperation from the responding party. So the first participant has already cooperated with them, and now they need to decide whether they will reciprocally cooperate the first player's decision and reach this mutually beneficial result, or whether they will now take advantage of the first decision maker. Well, they cooperated with me, thanks very much. I'm going to take the whole winning at the first player's expense. So it's a decision whether I reciprocally cooperate the other player's decision, or whether I exploit them for my own benefit. And as you can see, in human-human interactions, the majority of people are reciprocally kind. They reciprocate cooperation of others. And now what happens when people interact with artificial agents? So in the initiation step, when people need to choose between cooperation or playing it safe, whether they trust that the other will be kind, the majority of people cooperate with artificial agents as well. So it means that they truly trust these agents to be as kind as they trust other people to be kind to them. But the massive difference occurs in the second step of the game. So when a human decision maker has to now respond whether they will reciprocally cooperate an artificial agent's nice behavior, or whether they will exploit them for their own selfish benefit, well, here, people are very happy to exploit artificial agents. So in other words, they expect an artificial agent to be kind and cooperative, but in return, they don't reciprocate that cooperation, and they just take advantage of a nicely behaving artificial agent and exploit that agent for their own personal benefit. Okay, so these are findings that we find in multitude of games. These findings have been replicated by other researchers as well. And then there appears a question, so why that is the case? Okay, but before I go that, a new term. So we call this phenomenon that people are keen to exploit artificial agents for selfish gain much more than they are keen to exploit nicely behaving humans, algorithm exploitation. So why does this happen? Why is it that people are keen to exploit artificial agents? Well, to find out why, we look at how people emotionally respond to various outcomes of their interaction with other humans or with artificial agents. And in particular, I will focus on the case where they exploit others. So once a human participant has exploited their partner, another human or an artificial agent, we ask them, well, how do you feel about this outcome? Do you feel happy about it? Are you victorious? Do you feel guilty? Do you feel disappointed? Do you feel angry? And so on. And what do we find is a clear difference between how people emotionally respond to exploiting other humans versus exploiting other artificial agents. So when people exploit a human, they tend to feel quite guilty about that. So even though people sometimes do it, sometimes they do exploit a human, when they do that, they report a lot of guilt and disappointment. Some people still feel guilty about exploiting artificial agents, but they feel much less guilty about that than about exploiting a human. On the other hand, when they exploit an artificial agent, they report feeling much more happy about that and much more victorious about that than about exploiting a human partner. So summing up these behavioral findings and findings from people's emotions, we can now make some predictions of what will happen in these sort of chicken-like interactions in mixed traffic, where some human drivers or pilots are mingling with automated vehicles or drones on roads or in the airspace. And the prediction that we can make, because many of these traffic interactions are these mixed motive game theoretic settings, where it's, on the one hand, it pays to cooperate with others for mutually beneficial results, but on the other hand, it is tempting to exploit well-behaved others for selfish gain, is that, well, unmanned automated vehicles will likely get stuck in traffic much more so than human-driven vehicles. And why is that? Well, it is because other humans whom they encounter on the road will not give them way. So imagine a scenario where we are in a rush hour in peak traffic, and the traffic is slightly jamming up, clogging up. And here is somebody standing on the side road in front of you who wants to enter the main traffic in front of you. And they are waiting for somebody to let them join the main road. Now you are on the main road and you look at this other participant. Now, normally in human-human interactions, you see them, you see them looking at you. You know that they're in a rush just as much as you are in a rush. And we are in these situations quite kind to one another. We slow down for others. We let them join the traffic. We compromise sort of our own personal interests. But what if you are facing a fully automated, let's say, an empty, let's say, vehicle? Well, it's very safe, it's very kind, and it's waiting for someone to let it join the traffic. Would you still slow down for that kind of robot and let them join the traffic in front of you? Or would you be more tempted to push on and sort of hope that somebody else will let them join the traffic behind you? So these are types of predictions that we can make from these behavioral studies. Okay, there's many other things that I could show you, but maybe it's time here for me to stop. These are my co-authors and colleagues on and Bahdor and a number of others with whom we're working on these projects, but I would very much like now to hear what you think and to bring this into Q&A.
Excellent. This is a fascinating stuff and fascinating study as well, Jurgis. Thank you for sharing your high-level views. I think it really opens up a number of questions, you know, when we apply both scalability of unmanned traffic and also unmanned traffic operating in a mixed traffic mode with the manned traffic itself. And then the increased complexity, of course, because a lot of these unmanned automated vehicles, hopefully in the near future, will be operating at low altitude, and therefore they'll be closer to people than the manned aircraft are, because they're much higher. Now, let's start the questions. And first of all, may I request, I know that in the Q&A questions have started to appear. So thank you very much for those who have already submitted their questions. May I kindly request others to post your questions as soon as possible, because then we have more of an opportunity to having them addressed. So let me start with some of the things that I came up with when I looked at your presentation. Now, public acceptance of drones and UAVs is not easy, and I highlighted that in the introduction as well. And a lot of work needs to be done. And it's also reflected, the need to do that work is also reflected in the EU Drone Strategy 2.0 that was released in November 2022 by the European Commission. Now, public has concerns about the safety, security, noise pollution, and breach of privacy due to drone operations. These are some of the ones that they highlight in general. You've just highlighted how your research has shown the interaction of humans with humans, and then the interaction of humans with an artificial agent. And of course, as you highlighted, your finding, which is quite intuitive, I would say, is that humans would be slightly less benevolent in reciprocating to a compromise with an artificial agent. Because, as you said, one, they don't feel guilty because it's not a human that they're doing to, and secondly, there's a feeling of hurrah, victorious, I beat the machine kind of thing. How difficult is it then in this case? Let's first look at the challenges, and then we move into the opportunities. How difficult is it then that if we were to use artificial intelligence in enabling the drone operations to further convince the same members of the public who are skeptical to start off with? Could you give us a sense of what your research shows, whether there are any ways that we could use to overcome this challenge, please? And to either of you, Bahadur or Jurgis, you could take your pick.
Jurgis, you go ahead, and I will join.
Right. Yeah. So so we here focus on these situations where where trust has this inter-agent component, put it that way. So it's not about the case. So what in these studies we focus not so much on cases where a human user of a machine is going to trust using that machine to make decisions on their behalf. So here we are investigating trust of a human who interacts with a machine that is somebody else's tool, right? So that's what happens in traffic. So if I'm a cyclist on a road, or for example, and I encounter another robot vehicle, now I need to trust that vehicle being safe, kind on the road, but it's not my tool. And so what we see here that in this particular context, people trust them, these machines. People trust them to be kind, and perhaps that's linked with much discussed debates in policy and regulation these days, that they have to be safe, transparent, explainable, and benevolent, and so on. So what this shows is that this really reverberates into people sort of thinking about the machines, like, yes, the machine will be cooperative. How can it not be? So and it's nice that we see that kind of appearing in these behavioral studies. Right. The problem is that lack of reciprocation from people, and that is a more difficult problem to tackle, because to convince people that, well, you should be as kind to machines as you are to other humans, is a much harder problem. Why should you be kind to a machine when you are mingling in traffic? So yeah, I mean, one thing you might want to try and do is somehow highlight to the society why we are developing and introducing these agents into our society, and to focus on these more long-term vision that, look, this is for all our collective benefits. This is for all, for better transport system, for more safety and more efficiency, and to hope that this will be somehow picked up such that we will not be tempted to take advantage of these agents in traffic. But it is not an easy thing to do. The lack of sort of the temptation to exploit others is a problem that's in social affairs has been around for ages. Overfishing in open waters, tackling climate change, problems that we collectively have to deal with. But it's often tempting in all these sides not to play your part for the greater benefit, and hope that others will do that. So it's not an easy challenge to overcome. But Bahadur, maybe you have some further thoughts.
Perhaps what I wanted to say in response to Manish's question was to tease out the problem of what we call trust and trustworthiness, and separate the trustworthiness from concepts which are much closer to the engineering side, which when conceptually defining them, we might benefit from calling them reliability issues. So we might think of making a system that is very reliable. It's very accurate, it's very robust to noise, it's resilient, it doesn't break down, and all of those things. That's one side, which I think when thinking about this conceptually, it's better to call it reliability. But the matter of trust and trustworthiness in human terms, I think, requires something that is missing in that relationship, and that is a concept that philosophers and psychologists have been able to identify as vulnerability. I give you an example, and you will see. You go to a shop and you see that the shop says that we are so confident of the quality of the product that we give you that we take if you buy something from us, we are happy to give you a refund within the next 1 year. If anything happens, no questions asked, you bring the product back and we give you a refund. Now, what are they doing here? They're making themselves vulnerable to the customer. They're making themselves vulnerable to a loss by saying, if you happen to not like what we give you, we will refund you. This vulnerability creates trust in a psychological and philosophical way, conceptually very different from we give you a very good product. Here it is durable. It is like reliable, robust, etc., etc., etc. I think one of the key concepts that drone industry, artificial intelligence, and any one of the very concept of interacting with agents that are not human but are autonomous. The problem of trust there resides psychologically, mainly in that it is very difficult to persuade people that the unmanned vehicle is vulnerable. And it is a big part of this challenge for making the two sides trust each other, in the sense that we think of how humans trust each other, comes from that missing element in the other side. I hope that this conceptual distinction answers the question of what is it that trust requires, and why is it so difficult to initiate trust in unmanned vehicles.
That's a fascinating dimension you just introduced, Bahadur. I think I like that, which is to look at the lack of trust through the prism of vulnerability, and then to see how we can convince humans that this AI agent that they're looking at, which drives the drone in this case, how can you convince the humans that that agent is not vulnerable, that we can manage it? We can manage it safely, securely.
No, the other way around. How that system is vulnerable to something that to your whims and interactions. In the same way that if I am a customer and I bring back the product to you, you give me a refund, right? You make yourself vulnerable to me, and that vulnerability that you create for yourself allows me to trust you.
Excellent. Thank you for that. That's good. I have a number of questions on top, but I'm afraid there's a flood of questions from the audience. So I'm going to open the floor and take a lot of these questions from the audience, and in no particular order. Here we go. There's Wiebe de Jager, and he asks, I am wondering how a human being is able to discern a human/remote or remotely operated drone from an AI-operated autonomous drone in the first place. Okay, that's an interesting question. I don't know if a drone is flying outside right now. How do we know that it is AI enabled or not, unless we tell them that this is a drone that is enabled by an artificial agent or not. I think in the question lies also perhaps part of the answer in future. I feel that maybe in future, as we move from human to human interaction to human to artificial agent interaction, in order to go step by step, perhaps we create some corridors first to highlight that in these corridors we are using drones or flying drones that are operated by artificial agents. So not completely everything, just to study how it goes, and then to slowly move into other areas, which is also an idea that Mesut Yilmaz from Turkey has highlighted, which is to create designated routes and pathways, and then move forward. There's an anonymous attendee who asks, except for saying that it will be to all our benefits, how will we make artificial agents socially accepted or trusted? I mean, you've kind of touched on that in your presentation itself. Maybe another aspect both Bahadur, yourselves, and Jurgis could share with our audience is whether you've done any research, not just in drones, but in other modes of transport, for instance, automobiles, and if you've got anything that you can share from there with our audience to help them understand that, that'd be very nice.
Maybe I can start, Bahadur. Yeah. So these are very excellent questions. So maybe I'll start with the discerning AI from human operated vehicle or a drone. So yeah, indeed, I think this is where things are quite different in the drone traffic from traffic on the roads, because indeed, I think it's a good point. When it comes to drones, it's much harder to know which drone is operated by a human, which drone is operated by an AI, and it's easier to see that on the road, where you just simply see other people either operating or not a vehicle. That's a very good question. So one suggestion, and I'll start maybe here very briefly from interactions on roads with vehicles. One suggestion might be that, well, okay, if people will take advantage of automated vehicles on the road, well, one solution might be not to make them fully transparent, in a sense, not to disclose to human traffic participants that, oh, by the way, this vehicle here is automated. So, some sort of film imagination, you put tinted windows on the vehicle, you remove the indicators that it's automated, and so people might just think, well, maybe from this year, from some time onwards, suddenly there are many more gangsters or VIPs driving on the roads, but they might be human. So let's be kind to one another. It's possible, and some game theory studies suggest that when we interact with others and we don't know whether it's a human or a machine, that mutually beneficial cooperation can emerge and can be sustained. But immediately, as soon as people are told, well, now you're interacting with a machine, again, that cooperation drops from people. So this is one possible solution, to try and not to disclose to people that they're interacting with a machine, but that immediately brings up ethical challenges and problems, because current regulations demand that when you interact with someone, you should be told outright that this is a machine, this is not a human. So that needs to be, it makes sense for that policy to be there to regulation, but that removing transparency can improve cooperation between humans and machines, but that comes at the cost of transparency, which is problematic. And then there is another side to this. It's that, suppose that you interact with these vehicles, and maybe this is more speaks to now specifically drones, and you just know that, look, many of vehicles around are automated. So you know that many of them are robots. And in those cases, if you are tempted to cooperate slightly less with the robots than with machines, the danger here might be is that your sort of lack of cooperation with others might now spill over into your cooperation, lack of cooperation with other people. So even though here, you're interacting with another person or person-operated machine, normally you would be compromising with them in kind. But now you think, it's highly likely it's a drone, so I'll take advantage of them. Now that would not be an attractive future. Yeah, and just a very quick comment before I hand it to Bahador about there was a suggestion that maybe we should have designated routes and pathways for automated vehicles, and that's indeed that is a very good solution. So in a way, this suggests maybe we should try to avoid mingling on the same road or in the same pathway with automated vehicles. And maybe it's better to keep sort of human-operated vehicles in one lane or a pathway and automated ones in another one. And then these problems will not arise. And I think here it's a good example again with drones, because with drones, there's this new airspace for which we are creating new rules. We are not yet dominating the skies at this place where these drones will fly around. So there are opportunities to create these dedicated pathways. This is much harder on the road because that means recreating the whole infrastructure of road traffic, which is very expensive and difficult to implement, to introduce separate lanes for, let's say, automated cars and human-driven cars. So it's easier to do that in the drone space. So I think that's something that is promising. Bahador, do you have some further thoughts?
Yes, I think I will. The second question was the one that said, except for saying that it would be to all our benefit. Is that the question that you were referring to, Manish? How will we make these artificial agents socially accepted or trusted, right?
Yes, that's right, Bahador. Thank you.
That's the one. I think that question is very similar to the one that was posted first by Piotr SZ, who said that shouldn't we rather take into account the long-term safety of everyone? And the interesting point here, I think, in these questions is that these questions reflect a very long-standing debate in game theory and theory of cooperative versus competitive interactions. And Jurgis himself is also an expert on that, which we can think of as what is the right way to think about an interaction? Are we in this together as a team, or is every man for himself? And it is the very nature of traffic interactions. It's the very nature of these kind of game theoretic models that we introduced you, that everybody can see them either as I am late, I need to get to where I need to be, so I don't care about other people. And in a lot of situations, we are in those positions. We do feel that for a lot of us, these problems can be very easily framed as my problem, every man for himself. And it is also sometimes possible. A lot of game theorists have tried to say that in many situations, humans are capable of team reasoning, and they are capable of thinking about what is it that can I think of this situation as a situation in which a certain action benefits everyone. Now, both of these questions, I think both the difficulty that these questions raise and kind of like there is inherent in them, there is this question of, isn't it obvious that this is what we should be doing? I think that incredulity in these two questions reflects how subtle and how difficult to manipulate that frame of team reasoning is, and how despite the fact that it looks very reasonable, it's very easy for it breaks down very easily, and it's very fragile. Jurgis, perhaps if you could add something on the team reasoning on these two specific questions. I think they are very close to the concept of, can we think of traffic as a team reasoning problem? And psychologically, what I want to say is the difficulty is that human mind is not really easy to maintain in one versus the other. And we are very quick to move from one mental state to another and back. Is it good for everyone, or is it just good for me?
yeah, I can add just a couple of more thoughts. So yeah, that's where you're right. So team reasoning explains often why is it that we humans so often cooperate with other humans, even though we could take advantage of them in that situation. So in a way, we team reason. So this mutually beneficial compromise that we reach in traffic is an example of team reasoning. So you know, I'm a cyclist and I cycle in Munich everywhere, and I have small kids, and sometimes I'm in a rush to pick them up from a kindergarten, you know, and you know, so let's say it's raining and I'm in a rush and I'm leaving work and cycling very fast, but yet, you know, there's many others in the traffic and I'm in a rush, and we come to this situation. Well, here I am and here's a driver, and I could just cut them off, or I can slow down, and I see them and I recognize that most likely this person is also in a rush. You know, maybe they're rushing to the supermarket before it closes. So we do compromise, and it's like, yes, you are in a rush, I'm in a rush, and we slow down for one another. But what some of these behavioral studies or results so far that we have show is that this willingness to team reason is much harder to establish with an automated agent. It's much harder to think like, yeah, I'm in a rush, but the robot is probably also helping some human somewhere down the line. And it probably always is. If you think about it, we will probably never have robots roaming around around us for their own sake. They will always serve some human purpose. So there will always be a human behind the robot, you know. So even if it's fully automated drone or a car, it's delivering a package for somebody. There is some human waiting for it down the line. And this brings a good point to some of the things which we're studying now. So what we are in the next steps, what we are very interested in studying is this, what we call social distance between me as a human and the other human that is behind the robot. How far that this, where is this other human? It is somewhere. And the more I think about that human behind the robot, the more I should be willing to team reason with the robot as well. So yeah, this is something that we're looking into in the future, and I think it's going to be very important to study how increasing or reducing the social distance and how we think about our interactions with others will affect our willingness to cooperate.
Thank you both of those. The questions are coming, no doubt, and so please do continue. Thank you for giving us an insight on that one. No doubt, and as Mesut Yilmaz points out once again in his comment, that one of the things that will be needed, of course, in future is also educating people on how to accept perhaps an AI agent-driven vehicle. And today, I know there's a big debate going on, certainly at a larger level, at the level of artificial intelligence in general. And I know that in the UK, they've got a paper right now that's out, which has kicked off a debate on how to regulate AI agents or technologies driven by AI agents. It's a huge topic. Now here at Eurocontrol, where I work, we deal with conventional manned aviation, and we also have an AI Fly forum where a lot of the research is being done in manned aviation on the use of AI agents. And I'd encourage members of the audience to sign up to that, because we've got a big event coming up in the next few weeks where you can actually look at the outcome of research, but not just research, but also actual operational things that we're doing in manned aviation. And we're actually using a lot of those algorithms, if you like, to help with flight routes, efficiency of routes, and such like. Now, there's a follow-on question from an anonymous. And no, there's a follow-on question from Weber de Jager, who we pointed out earlier. Most AI-operated drones will be backed by human operators in case something goes wrong. So could you see, or could you even define an AI-operated drone as such isn't it a mixed definition anyway? It kind of points to the sort of thing that you were talking about, Jurgis, where you're trying to figure out the distance between a human and a human behind the AI agent. What sort of research are you doing there, and what's the dynamic then between not just the human who's looking at the drone enabled by AI, but the dynamic between the human that's controlling the AI agent itself? Could you share your views on that to help Weber, please?
Yes, maybe I can first put something there as a like bracket before we get to the DLR in London. The on sort of on surface trains in London have been experimenting with having unmanned trains, and as a consequence of the accidents that have happened, they have come to update their test by having a DLR officer on the train, not in the driver's seat, but on the train. And what you read from the report is that this is totally counterproductive. The whole point of the DLR trying out was to cut down on that extra officer. If I put an extra officer in the train without them doing anything, then I have decreased productivity by a large amount. So that complication, I think, is important, especially when we go to large scale, and a big part of the reason why the whole raison d'etre of why we are interested in unmanned vehicles largely depends on vehicles going around by themselves rather than having someone sit there, waste their time. So that is one aspect. But with much closer relationship to what you said, the role of distance between and psychological distance, and how psychological distance can make people approach the same problem differently or similarly. I give you an example from a different study, which is kind of like informative in terms of the function of distance, but we would have to accept a sort of like, and that is, there are studies on cheating and lying that tell you that if you allow people to cheat and benefit directly with cash, very few people do it. But if you tell them that or if you make the situation such that they can get a token, that token can then be transformed into cash, the cheating becomes a lot easier. This means putting one step of distance between the cash and the person makes the process, facilitates the process a lot. So you can see that how this concept of whether the thinking about what is the distance between the drone that I am interacting with and the human that the drone is serving, how decreasing and increasing it can be persuasive factor for the humans. Jurgis, if there is anything to add, I would be happy.
Jurgis, just before you do that, because I think there's a related question that I'm going to throw in now, because time is limited and you can cover them both. Someone with the acronym FJA asks, how about acceptance of AI in the manned air society? Think about police, ambulance, helicopters. So basically he's asking, he or she is asking the use of AI agents for enabling drone traffic when the drones are being used to deliver essential services, to save lives, to control mobs, to do things that are for the benefit of the people. Are there cases where people are likely to accept the use of AI agents for those kind of operations, other than, let's say, using drones for delivering coffee and pizza? Over to you.
Sounds good. Well, I can start on this one maybe. So yes, that's a very good point. And it highlights how important it is that people will cooperate with these essential services like police, ambulance, and so on, or drones delivering, I don't know, blood or organs between hospitals and things like that. So certainly. And I think it's crucial that people will cooperate with them, but there is another component here which is important, that already on the road, well, we have a very clear hierarchy on how we are supposed to interact with these vehicles on the road. So this is a case where it's not sort of often left up to us, oh, will you be kind or not? It's also that if you hear sirens and you see the blue lights, you know that the rule book requires you to stop. Right? I mean, you can still try not to do that, but you know, and the social sort of pressure on you to do that is very, very high. So in other words, we have clear rules on how we're supposed to behave in these situations. And that nicely connects with one of the other points that you mentioned earlier about educating people. So educating people, yes, that's one thing, but there is another thing, create more rules for interaction. Right, something like this happened already in Estonia, where these self-driving robots are used to deliver pizzas, actually, as you mentioned, food. And there was a problem. So there were more and more of them available on roads, and there was a problem that people raised, that they didn't know how to behave when this robot is waiting at the pedestrian crossing. There was a confusion. Are we supposed to slow down and let them cross, or are we supposed to ignore them? So a new regulation was introduced. No, if a robot is waiting at a pedestrian crossing, you have to treat it like a human pedestrian. You have to stop. So that's one solution here. Introduce more rules. And when it comes to emergency services, I think that's possible and makes perfect sense. When it comes to more sort of, somebody delivering an Amazon package, it's becoming a bit more questionable. How many more rules do we want to introduce into how we are supposed to behave in traffic when it comes to that? But that's a very good point. Yeah.
Thank you, Jurgis. I think we've got to that stage where there's only 3 minutes left to end this webinar, and I'd like to use this opportunity and these 3 minutes to do a wrap up and thank everyone for being in here. Ladies and gentlemen, I'm sure you'll agree with me that this was a very interesting topic. Certainly I enjoyed it. Often we talk about technology-related things, but this is a topic that connects technology to humans, because we need to deal with it. Without dealing with it, we cannot achieve public acceptance. If you cannot achieve public acceptance, then it doesn't matter how much of a good solution we produce. If it's not accepted by people, we won't get the scalability. There won't be a commercially viable case for the drones to fly, and then that's not a situation we want to be in. But today we have learned from Bahadur and from Jurgis that humans trust each other, at least in majority of the cases. They're happy to trust each other and to reciprocate. However, when it comes to reciprocation, humans reciprocating to AI agents, that percentage is much lower. And that could be because they don't see, they don't have that soft feeling of guilt if they were to not reciprocate to their demand. And also the geeks amongst us would like to actually be challenged by the technology and try to beat them. So there's that dimension of humans. Now, what was very interesting was your example when you highlighted what would happen if an unmanned automated vehicle, a drone enabled by AI agents, would get stuck in the traffic. What would happen? What would happen to it? And right now, I think it's more questions than answers. But what is important really is to understand whether humans can be as kind to the machines as they are to themselves. And with the help of the questions we had from the audience, we learned that, yeah, there's a need to educate humans on how to behave. You highlighted that we perhaps need some more rules and more regulation to define a kind of a charter between citizens, humans, and AI agents or AI-enabled technologies. You, Bahadur, highlighted to us, whilst on a technical front, we can look at reliability in a system and try and see that as a way of achieving safety and security, if you like, from a technical perspective. Yes, you can. But I was fascinated to learn from you, and I'm sure the audience were as well, is how important is it for humans to understand that the other entity dealing with me is also vulnerable? and also to understand the vulnerability of that entity, which is, in this case, the drone perhaps enabled by an AI agent. Very interesting. Never thought about it in that way before. And of course, there's the members of the audience asked the questions and also made suggestions that perhaps in our journey to using or asking or motivating people to accept AI agents to help with the drone services market, perhaps we could create different pathways. And one pathway for AI agent operated drones and the other one for human operated drones. I don't think that would be in essentially the long-term solution, because as Bahadur highlighted, we probably will lose productivity then. But that could be one of the phases that we introduce from where we are to the phase that we want to have, where AI-enabled drones are easily accepted by public. So a lot to learn, a lot to do, but I'm delighted that we have learned something new today. And thank you very much both to Dr. Bahadur Bahrami and also to Jurgis. Thank you for sharing your views. Ladies and gentlemen, I would encourage you to sign up to the next month's industry update from Amsterdam Drone Week as we bring you more and more interesting topics. My name is Manish Khurana. I work for Eurocontrol, and we're in the business of safety of air navigation. Have a pleasant day and goodbye.